The objectives of this video are being able to find zeros of a simple quadratic function by using square roots, and be able to find solve simple quadratic equations by also using square roots. Square roots are used as the inverse of squaring a number. So whenever you see a power of 2, if you want to do the inverse of it, you would square root both sides of the equation. And the first objective says find zeros of each quadratic. A zero is sort of like an x-intercept. It is the x value that makes the value overall of the function 0, which they end up lying on the x-axis. In order to find out what zeros are, you set the value of the function, or f of x, equal to 0. So in this first equation or function, I'm going to replace f of x with 0. Then once you solve for x and you get values for x, those are your zeros of the function. So starting to solve for x, I'm going to highlight x, and you're going to be able to see all the things you need to do the inverse of. So I have plus 75, I have times by negative 3, and then I have that power of 2. You do the inverse of all three of those in the correct order. Order of operations says exponents comes first, then multiplication, and then addition. When we're solving, we go with the reverse order of that. We're first going to undo the addition, because that's at the bottom of the order of operations pyramid. You undo that with subtraction. Subtract 75 from both sides. That should get you your 0. 0 minus 75 is negative 75. You're left with negative 3x squared. Now divide both sides by negative 3, because it's the inverse of the multiplication in between the negative 3 and the x squared. And you get 25 equals x squared. Now to get rid of the power of 2, you're going to square root both sides. And x is going to be equal to two numbers, plus or minus 5. Or you could write it like this: x equals 5, x equals negative 5. Why the two numbers, you might ask? Well, the square root is a way of finding out what number multiplied by itself will get you that number in the radical. So 25, if you multiply 5 times 5, both positive, you'll get a positive 25. If you multiply two negative 5s together, you will also get a positive 25. That's why there's two roots. You'll see further later, when we take a square root of a negative, what happens with the roots there. Number 2, still find the zeros. So we're going to replace f of x with 0 again to find the zeros that make the function value 0. And we have now created an equation we can solve for x. Notice how there is a multiplication of 2, there is a subtraction of 72, and then there's the parentheses and the power of 2. Order of operations says that the parentheses are done first. That means they're going to be done last in the whatever's inside them, last in the solving part. So the first thing we're going to do, work bottom up, we're going to add 72 to both sides. 0 plus 72 is 72, times 2 times x minus 4 squared. Then divide both sides by 2. 72 divided by 2 is 36. Rewrite it over here so we have some more room. 36 equals x minus 4 squared. Now to get rid of the power of 2, you're going to square root both sides. And you get plus or minus 6 equals x minus 4. Now the reason why I square rooted first before I added 4 to both sides is because the parentheses are done first in order of operations, therefore they're done last when you solve. Plus or minus 6, both negative 6 and positive 6, when you square them, turn into 36, so you need to have both. And from here you have two equations. You have 6 equals x minus 4, and you have negative 6 equals x minus 4. Two solutions to solve for. Add 4, x equals 10 over here. Add 4, x equals negative 2 over here. So those are your two zeros for this function. Let's go to number 3. Again, we're finding zeros, so you're going to plug in 0 for the value of the function overall. First step, we're going to add 10 to both sides. Next step, undo the multiplication of a fraction with the multiplication of its reciprocal. So multiply both sides by negative 2 over 1. That gets you negative 20 over here. And x minus 3 squared. The reason you multiply the reciprocal is that they cancel out to 1. Now, your next step is to square root both sides. But when you square root a negative number, you end up getting an unreal solution called an imaginary number. So what that means for our zeros, it means that there are no zeros of this function. It does not cross the x-axis whatsoever. And the reason is because negative 20, there's no number that you can multiply by itself once to get to 20. Because whether you repeat a negative number or a positive number, you get a positive result. There's no way to square a number and get a negative result and it still be a real number. So here you're going to write no real zeros. Because you cannot square root a negative number. Now there are imaginary zeros that don't appear on the graph, but we're going to focus on just the real numbers in these cases. Number 4, finding zeros. Plug in 0 here. This one should be pretty straightforward. Even if you go through and do the work, 0 divided by 2 is 0. Square root 0 and you get 0 for x. Now you're not going to write plus or minus 0 because 0 is neither positive nor negative. So you don't write plus or minus 0, you just write 0. This function only has one 0, but all the other functions, number 1 and 2 had two real zeros, number 3 had no real zeros. It is possible to get the 1 0 rather than opposed to 2. It is also possible to get none or no real zeros. Now that's finding zeros of a function. When you just have an equation, you're using the same method to solve for x. It's just there's no function involved. It's just a equation that's put together. So if you're solving for x here, you're going to use the exact same steps as before. The only thing you're going to change is you're not initially setting the equation equal to 0. You're just solving for x and what's given to you. So lowest on the total pole is a subtraction, so you're going to add first. Then comes multiplication. So you undo it with division. 27 divided by 3 is 9. Lastly, square root. And x equals plus or minus 3. Or you can write it just as x equals 3, x equals negative 3. Both answers. Either way is suitable. Just know that when you write plus or minus 3, you are talking about two separate numbers, not just one. This one here, you got multiplication here on the outside, and that comes after parentheses and exponents and order of operations. So you're going to undo that first by dividing by negative 2. And you're going to have x plus 4 squared equals 100. Negative 200 divided by negative 2 is 100. Then you're going to square root both sides. X plus 4 is plus or minus 10. Now you got to write two equations for the positive and negative 10. So x plus 4 equals 10. X plus 4 equals negative 10. And your one step for both equations is to subtract 4. Therefore, x equals 6 here, and x equals negative 14 over here. Now, the difference between finding solutions and zeros, these are just solutions to a random equation. And up here, these are actual zeros of a function, meaning that I can rewrite them as x-intercepts, negative 5, 0, 5, 0. They correspond to actual points on a graph. This is just an abstract equation, which may be used in a story problem or some other situation, but without that background information, you can't make any judgments on those answers. Here, you can actually say these are your x-intercepts because our zeros are 5 and negative 5. So using square roots is a useful tool if you have a power of 2 in your equation. It is the exact inverse of square